Welcome students, welcome to TKG physics classes. So in previous class we learned about the rules for formation of images by spherical mirrors, and the rules are: rule number 1, a ray which is parallel to the principal axis will pass through the focus after reflection. Rule 2, a ray which incident through focus after reflection it will pass parallel to the principal axis, that is just reverse. Now rule number 3, a ray which passed through the center of curvature is reflected back on the same path. And the final one, that is a ray which incident on pole is reflected by making equal angle. So in this class we will discuss about the formation of images by concave and convex mirror. Then we learn about the mirror formula, magnification, and some numericals related to mirror formula. So let's start the formation of images by concave mirror. First condition, that is when object placed at infinity. We know that when object plays at infinity, a ray of parallel beam of lights coming and incident on the mirror. And when a ray of parallel beam of light coming and they are meet at the focus point, so here image is formed at focus. Nature is real and inverted. Question is why real? Because real rays are meet here, and the size here, that is looks like point object, point image. Next, that is second condition, when object is placed beyond C, that is object is placed beyond the center of curvature. Just see the figure. AB is the object which is placed beyond the center of curvature, and for formation of image, a ray coming parallel to the principal axis, so after reflection it will pass through the focus, and another ray of light passing through the center of curvature, it will reflected back in the same path. So two rays meet at the point A dash. Here A dash B dash is the image of AB, and the position of the image is between C and F, that is between focal length and the center of curvature. Nature is real and inverted, and what is the size of the image? That is here image is small size with compared to the object. Now case number 3, that is object is placed at the center of curvature. Same method, one ray which is parallel to the principal axis passing through the focus point, and another ray which passing through the focus point, they is reflected as parallel to the principal axis as mentioned in the rules for formation of image. So they meet at the point A dash. Here A dash B dash is the image of the object AB, which is same size as object here, and both are placed at position center of curvature. Size same, position same, and the nature is real and inverted. নেচার কেন রিয়েল? এখানে আমাদের রিয়েল রে অফ লাইটগুলো এসে কিন্তু মিট করছে, তার জন্য নেচারটা হচ্ছে রিয়েল। ক্লিয়ার? নেক্সট ফর্ম, দ্যাট ইজ 4, when object is placed between center of curvature and focal length. So a ray which parallel to the principal axis passing through the focus point, and another ray which passing through the center of curvature by touching the heads of the object AB, and after reflection it will reflected back in the same path. So where the image will form? The image will form when both the rays are meet, and here the image is formed beyond C, beyond the center of curvature. Nature real inverted, and the size will be enlarged. That is, here object size is small with respect to image size. You just notice one thing here, when object placed beyond C, the image is formed between C and F, and here object placed between C and F and the image is formed beyond C. So these two conditions are just opposite to each other. Clear? Now case number 5, that is object is placed at the focus point. Same method, one ray which is parallel to the principal axis is passing through the focus point, and another ray which is passing through the center of curvature by touching the heads of the object AB, then after reflection it will return back in the same path. Clear? So just see the figure here, both the rays are parallel to each other. So where will be they form image? Both are parallel to each other. They never meet at a point. So we can say that the image will be formed at infinity. So the position of the image is infinity. Nature is real and inverted. And as the position is infinity, so the size of the image will be highly enlarged. So here image size is highly magnified with respect to object size. Notice one thing here also, that is when object is placed at infinity, image is formed at focus. Here image is placed at in focus and the object is formed at infinity. So here both the cases are reverse also. Now the final one, that is when the object is placed between P and F, that is between pole and the focus. So a ray which is passing through the center of curvature, after incident in the mirror it will return back in the same path, and another ray which incident on the pole, after reflection it will reflect it by making equal angle. So here both the rays are separated more gradually. So where the image will be formed? Image will be formed when both the rays are drawn in the backward direction. Just see the figure. If we draw both the rays in the backward direction, then they will meet at the point A dash. So here A dash B dash is the image for the object AB, and this image is beyond the mirror. So the nature of the image is virtual and erect, and the size is enlarged with respect to object. Why virtual? Because it is beyond the mirror, not real rays are meet. Imaginary rays are meted here. Clear? So here the table are given, and in this table you can see all the position of the objects, corresponding nature and the size of the image, and the uses of this particular position of that objects. So you can read it here at a glance. Now we have to draw image formation by convex mirror. There are two types. When type 1, that is when object is placed at infinity, and in this case when object is placed at infinity, a ray of parallel beam of light is incident on the mirror, and after incident it will diverges. Clear? So where the image will be formed? If we draw it backward line, then it looks like it will diverges from the point focus. So at focus point the image will be formed. So the position of the image is focused, nature virtual and erect, and the size is point size. And there is second option, that is when object is placed between P and infinity. So when object is placed between P and infinity, first ray, that is which is parallel to the principal axis, it is diverges from the focus point, and another ray we can draw which is passing through the center of curvature will be back in the same path. So both the rays here are separated more gradually. So if we draw it in the backward direction, then it will meet between the point P and F. So here image is formed between P and F as the virtual rays meet here. So the nature is virtual and erect, and the size is small with respect to object distance. Clear? So this is all about the image formation by concave and convex mirror. Now we have to learn about the mirror formula. What is mirror formula? At first, to study mirror formula, we have to know about the object distance, image distance, and the focal length. What is object distance? The distance between pole and the object is called the object distance, which is denoted by u. The distance between pole and the image is called the image distance, and the distance between pole and the focus point is called the focal length. And mirror formula indicates the relation among object distance, image distance, and focal length. And the formula is 1 by image distance plus 1 by object distance equal to 1 by focal length. That is, mathematically it can be represented as 1 by v plus 1 by u equal to 1 by f. Now we have to learn about magnification, that is called linear magnification. And magnification indicates the ratio of height of the image to the height of the object. If we consider h dash is represent the height of the image and h represent the height of the object, then magnification m can be written as m equal to h dash by h. Here m is called the magnification. And there is another formula of magnification, that is m equal to minus v by u, which is in class 12 in details. So one formula, that is m equal to h dash by h, and another one formula, that is m equal to minus v by u. So by comparing two equation, we can write m equal to minus v by u equal to h dash by h. So these two formula are important formula for solving numerical problems. So let's take some example for problems that is related to mirror formula. Problem 1. In the problem given, an object is placed 10 cm from a concave mirror and the focal length is 5 cm. You have to determine the image distance and the magnification of the image. So at first you have to write the given condition. Here given f, that is focal length 5 cm, object distance u, that is 10 cm. So according to mirror formula, we can write 1 by v equal to 1 by f minus 1 by u. So just putting the individual value and simplify it, the value of v will be 10 cm. So here image distance is 10 cm, and according to magnification formula, m equal to v by u, v and u both are 10, so minus 10 by 10, answer is minus 1. Here 1 indicates that image is same as that of the object. There is also two important point. When m will be more than 1, the image height will be more greater than object height. When the image will be less than 1, m will be less than 1, that is image height is less than the object height. Clear? So here minus sign indicates the image is inverted. Now problem 2, that is a 5 cm high object is placed in front of a concave mirror with a radius of curvature of 20 cm. You have to determine the image height if the object distance is 15 cm. So at first write the given condition, that is the radius of curvature r 20 cm given. So what will be the focal length? Half of the radius of curvature, that is 10 cm. Object height ho given 5 cm, and the object distance, that is also given 15 cm. So according to mirror formula, we can calculate the image distance v, which is 30 cm. Just simplify it putting the value, and therefore you have to calculate magnification, that is m equal to minus v by u, u that is 15 and v that is 30. So putting this value, m will be minus 2. Here negative sign indicates image is inverted. When m will be positive, that indicates image is real, the image is virtual. And here m is 2, magnitude value of 2, that means the image is twice times larger than the object. Then what will be the height of the image? As we know, m = height of the image by height of the object, then height of the image will be height of the object into m, that is 5 into 2, 10 cm. So height of the image is 10 cm. Now problem 3, there is an image by a concave mirror is 4 times greater than the object. If the radius of curvature is 20 times, then you have to determine the object distance in front of the mirror. So here magnification m given 4, radius of curvature given 20, so the focal length will be 10 cm. Now m equal to minus v by u, so m given 4, that is 4 equal to minus v by u. or simply cross multiplying it, that is minus v equal to 4u, so v will be minus 4u. Now according to mirror formula, 1 by f equal to 1 by v plus 1 by u, just putting the individual value and simplifying, we can write 16u, that is equal to 200, so u equal to 12.5 centimeter. So here the object distance is 12.5 centimeter. Clear? Here some also numerical problems are given, and to solve it and check your understanding level. So this is all about today class. For any queries, for any problem, tell me in the comment section, and in the next class we will discussing about the third part of the light, and this is the final part of light chapter. So stay tuned and thank you.